Well, yes, friends, welcome back to Pure Math School, and thank you for the new. If you're new to the channel, please ask you to subscribe at the end of the video, or to comment or like about the video, or say something about the video. Today we are continuing with Algebra 1, the first topic, and we are still reviewing the number system, algebraic expressions. So, and last time we looked at some of this one. We looked at use of the index form in our reviews, and we looked at term collecting of like terms, expansion of sum brackets, and I think actually today we're going to continue still with the SADs. We are trying to check on now, because I remember we stopped at irrationals and SADs. I can open to that. I think our previous work that we did was up to here. Okay. It was up to irrationals and SADs. Where's this thing? Yeah, here we looked at irrationals and SADs. Wait, these were some of the reviews we went through. We recalled the properties, the four different properties we use when we are simplifying SADs, and we also checked on some other. Actually, we basically looked at examples. We were reviewing some examples of what we actually, some of the things we did when we started introducing SADs in our introductory work. And today basically we're going to continue with rationalizing. Rationalizing the denominator. We already did that when we were introducing SADs in the under the introductory work. Maybe you can go back and check some of the videos behind there. So today this is what we are doing. We are going to review some few numbers and give actually just come out with a conclusion, or give a conclusion about the number line. So let us check on some examples we can touch today. Say rationalize this. Let me say rationalize. I didn't even put the heading. Okay. Let's say A is 5 out of root 3, and B, let me say it's 15 out of root 5. Then another one, C. Then I look at maybe one more complicated expression in the denominator, which is, let me say, 7 minus root 2. Under SADs, when we introduced SADs in the introductory work, we said that when you're rationalizing, for this case, if you have of the form, say 1 out of root A, it's just a matter of multiplying the numerator by root A and also the denominator by that same thing. But that's not actually the main thing. It comes from the foundation that you actually think of the conjugate. Even more complicated denominators, like say this denominator, when you're rationalizing, you still think of the conjugate. The conjugate, I mean that to have same components or same elements, but with a different sign. Since now for this case the sign is put in the negative, that means the conjugate of this expression 7 minus root 2 will be 7 plus root 2. So once you're told to rationalize, you think of the conjugate of the expression. Even for this case, we always multiply by root of A, or if for this ones of this form, we multiply by root of A divided, and we also multiply the denominator by root of A, simply because the sign will cancel. Here, remember, we have a positive here, but now if we put negative, multiply by the conjugate of this, which will be, because this 1 out of root A is the same as 1 out of 0 plus root A. Okay, you see that? So the same as multiplying by 0 minus root A out of 0 minus root A, which is still, sorry, you are not seeing that. It's still the same. It's the same as saying that root A, 1 out of root A, when rationalized, the same as saying 0 plus root A times now the conjugate, numerator multiplied by conjugate, which is 0 minus root A. Conjugate of this 0 plus root A is 0 minus root A. then divide by 1. You multiply also and also multiplying the denominator by the 0 minus root a, which is the conjugate of 0 plus root a. But now for this case, the result of 0 minus that will remain a negative root a, which even down here would bring 0 minus root a will remain a negative root a. In the end, you remain with multiplying 1 out of root a with only negative root a divided by negative root a. Okay, that's why these negatives will cancel out and will the negative divided by negative will turn out to be a positive. That's why we just conclude that is anyone, let's say any constant also there, say not 1, then we'll just multiply by that because a negative will turn out to be a positive. So that's what I can summarize about that. And now for this a part, we just sample it very fast. 5 out of root 3 be the same as 5, but if you're rationalizing it, we multiply the numerator by that same, because for this case then the sign will become positive. Even the denominator multiply by that. Okay, this is a multiplication. Okay, so now you see that this becomes 5 root 3. Down we remember we looked at root a times root a of that form becomes a. Okay, we looked at that earlier, so the a is just going to become 3, so that when you rationalize that it becomes 5 root 3 out of 3. That's how simple that one is. For b, when you look at 15 out of root 5, see the same thing. It's going to be the same as 15 times root of 5 out of root of 5 times root of 5. What will happen? You see that this will become 15 root of 5 out of 5. Root 5 times root 5 is 5. So now 5 will reduce that 15 to become 3 root 5. When you rationalize that, you come to that. Okay? So that's it. Let me check on C. C is actually saying that C is 1 out of 7 minus root 2. 1 out of 7 minus root 2. It's the same as saying that 1 out of 7 minus root 2 times, we multiply the numerator by the conjugate. I said conjugate, same component, but you change the sign. Then you multiply also the denominator by the conjugate. 7 plus root 2. Because the conjugate of 7 minus root 2 is 7 plus root 2. So we are multiplying the numerator plus the denominator as well, like that. So now the numerator will remain 7 plus root 2, 1 times the whole of that will remain that. So now, remember we looked at the form of a plus b into a minus b. Consider here a difference of 2 squares will help us a lot to simplify this very fast without expanding the whole thing. So that you know that here we consider 7 to be our a and root 2 to be our b. So that means we square a, then subtract with the square of b. Okay, what does it mean? Our expression has become, it's 7 plus root 2 out of 49, which is the square root of 7, the square of 7, minus, when you square 2, it's like saying root 2 times root 2. Okay, it's the same as root into 2 times 2, which is the same as root of 4, which becomes 2. So in the actual sense, we are going to have something like 7 plus root 2 out of 45. See, that's how we rationalize such a number. I think for that review, I've already told you about choice of conjugate, both cases. Let me make a conclusion for both cases. Let me say a constant out of root of a number. Still, you multiply your and say, let me say anything up. Let me also say constant out of some other number minus root of another number. Okay, consider conjugates. Okay, keeping that's meaning keeping components, same elements. So actually I can say keeping the same yeah, actually how can I say elements? Yeah, I could talk of that. I can say same components or the elements. Let me say components. Okay, but changing sign. Okay, I already told you this, that why it will remain only root a times root a, because the sign will cancel. The always the signs will turn out to be a positive, even if there was a minus here and now you're multiplying by plus and plus, still remain a plus. So that's for that case. For this case it's obvious, because now that when the sign changes you have to expand. And you realize that here, since the conjugate, the difference of two squares is very important. Okay, let's look at one more example. Let me say example 2. Okay, rationalize root of 17 minus root 5 out of root of 17 plus root of 5. Okay, now for this case, still the same concept we used here. Don't fear the numerator, however big it looks, it does not affect us. It doesn't concern us. Our concern is to get the denominator, because we are basically rationalizing the denominator. When you're told to rationalize a fraction which has surds in the denominator, it's actually rationalizing the denominator, or making the denominator a rational, actually, okay, making the denominator, I think, a rational number, but rather than having an irrational number down there. So now let's say that 17 root of 17 plus root of 5, okay, out of root of 17 plus, is it, hey, up here is a minus, sorry, and here the root is not for, this root is for only 17. Sorry, I made the mistake, I think. Here is a minus, sorry, here's a plus of root 5, will become 17 root then minus root of 5. That is the numerator. We are multiplying our numerator by the conjugate of the denominator. The conjugate of the denominator, same components but change the sign. So you have 17 and the root minus now root of 5. Okay, out of that same denominator, okay, multiply it by its conjugate, which will become root of 17 minus root of 5. Okay, now if you expand this, remember this, we can just apply our now, since we already covered identities in our introductory work, we don't have to suffer a lot. Something like this will become something like that. Okay, so we let our a be this, and our b, since we have minus same components, so that here we're just going to square a, which is root of 17 squared minus 2 times root of 17 times root of 5. That's minus 2ab, then plus root of 5 squared. Okay, we don't suffer, but if we already know those identities, so we just use but if you feel like you can expand the normal way by making each term in the first bracket to multiply this second bracket, which means it will also multiply each term here or multiply each term here, and you can maintain the signs. And now we can see that this one, we still difference of 2 squared, which means only root of 17 squared minus root of 5 squared. Okay, that's the difference of 2 squares. We're not going to start with that, we already know, I think. So now root of 17 will remain 17, root of 17 squared. We have here root of, we can see 15 times 5, is it some exact number that we can have a root afterwards? This is 17 times 5, it's 85. I don't think it's not an exact root. We don't bother about that, we just leave it as root 85. So it's 2 root 85, 2 root of 85. Then root of 5 squared will remain 5. It's a plus 5. Out of 17 squared will remain 17 minus 5 squared will remain 5. Okay, what do we have then? 17 plus 5, these are just constants without a side, so we can combine. That's already 22 minus 2 root 85. Okay, out of 17 minus 5, 17 minus 5 remains 12. Okay, we can reduce by 2 because you see 2 is common there, so for rather 2 remain 11 minus, we're going to have 2 into 11 minus root 85 out of 12. So that 2 reduce this to 6. We're going to have something like 11 minus root 8 5 out of 6. That's when you rationalize. That's what we have, this, and rationalize that. Okay, so I think now we can just make some simple conclusion about. Now we have realized that surds are basically those roots of numbers which are not exact. Let me say root of 4 is not a surd because it has an exact number which is 2. It has because 4 is a square number. But now those non-square numbers are when you get the root of non-square numbers, that's when you have a surd. So surds are irrational numbers. And before, remember that our real number line consists of both the rational numbers and irrational numbers. That's what we can conclude about the number system and surds. I think we have, that's a simple way we can review our number system, our real number system, and maybe some algebraic expressions that we looked at in our previous video. So I just want to say that thank you for coming to my channel. Please keep following my videos. I know I'm going forward and I'll keep improving. Please don't forget to subscribe to support me. Thank you.